Okay, still in chapter 7.5, let's do some compound interest examples. So let's look at the problem up above where we have P equals $1,000 and R equals 0.08. But let's compound monthly for 3 years instead of annually like we did before. Okay, so here's our formula we're going to use again. We're going to use our compound interest formula. A equals P times quantity 1 plus R over N to the NT. So based on our problem up here, let's decide what we're going to use for values. Okay, of course, P is 1,000, goes without saying. And R is given to us, 0.08. It's our annual interest rate. And T is 3 years. Got that from here. That leaves us with N. So what's N? Well, N I'm going to derive from this idea that we're compounding monthly. And that means there are 12 compounding periods per year. So N is 12. And I wrote these down up here in this little chart too, so you can reference that. So this is our number of compounding periods annually. And the reason this is done annually is because our interest rate is an annual interest rate. Okay, let's put these values in our equation. It's just plug and chug time. Little cookbook at this point. It's 1,000 to the 1 plus R 0.08 over N, which is 12, raised to the power of N, which is 12, times 3. You do this calculation, you get $1,270.24. So over 3 years, if you compound monthly at 8%, you're going to accumulate $270.24 in interest on your $1,000. You can see that's a little bit bigger than when we compounded annually here of $1,259, and even bigger, both of which were bigger than when we used the simple interest approach. Now, when you do these calculations, you really want to do this, type this into your calculator in one shot without rounding. If you start rounding, you're going to start accumulating errors. So if you have a somewhat modern calculator, just type in this equation as you see it. If you don't have a modern calculator, then here's the approach I would suggest you use. You do this calculation first. We're going to kind of do an order of operations idea. You do this calculation first, 0.08 divided by 12. You press the equal sign. You're going to get a number. You add that to 1. So now you've done everything inside this parentheses. So you're going to have 1 point something. So then you take that number. You don't round it. You just leave it in your calculator the way it is. You press your button that raises things to a power, and you raise this to 36. Then you hit equals again. So now this whole thing will be calculated. And then finally, that number that's residing in your calculator right there, you just say times whatever your principal is. Here it's 1,000. That's the approach I would use with a calculator. So these problems might seem complicated initially, but if you just are careful, if you write down your variables so you can see where you get them, and you're careful about pulling your information from your word problem, the process is actually not too bad. Let's do another type of example. So we can also use algebra and go backwards if we have other pieces of information uh, in our, let's see, let me write it here, in our formula. If we have the final amount but we're missing our principal, we can always do some algebra here and solve for p. We could say that p equals a over 1 plus r over n to the nt. This would be what we might call a present value formula. I don't think you need to memorize this. Uh, just learn to do the algebra. And if you're going to memorize anything, memorize this formula. And it's a formula that it actually is not too bad to memorize after you practice with it and done half a dozen to a dozen practice problems. You'll have this formula memorized. So let's do an example of one of these present value problems. So here's our problem question. Suppose you want to go to Tahiti on vacation in 5 years. You realize that you'll need $5,000 at that time to make that happen. How much money should you invest today at 6% if it's compounded quarterly? Well, using our derived equation above, let's pull values we need. We're going to need an A, an R, an N, and a T, it looks like here, because we're going to solve for P, because we're looking for a present value. So A is, looks like 5,000. That's our future amount, $5,000. Our rate is 6%. Our time, well, we're giving ourselves 5 years. And over that 5 years, each year we're going to compound quarterly, or we're going to compound 4 times. Okay, cookbook now. Let's stick these numbers in our relationship. 5,000 goes in the numerator. That's our A. Denominator is 1 plus r over n, 0.06 over n, 4. This is raised to the nt, or 4 times t is 5. 4 times 5 is 20. So it's raised to the 20th power. So again, let's do one calculation in the calculator, and let me do that calculation, I think. So this calculator that comes with Windows is advanced enough that it has parentheses, and it has this x to the y power. So you could type this formula in exactly as it's shown here. And let me do that actually. So 5,000 divided by, and then I'll have parentheses, 1 plus. Now since I know this is going to follow order of operations, because I've tested it already, I will just go ahead and do 0.06 divided by 4. And then I have to raise this to the power of 4 times 5 is 20. Hit equals, and I get 3,712.3, let's go 36, we'll round up, 36 cents that I need to start out with. So I have to deposit that in the bank, and I know if I just leave it alone at 6%, it'll grow to 5,000, and I'll be ready to go on vacation. If you have a calculator that doesn't have all these bells and whistles, then here's how I suggest you solve this problem. Go with the order of operations 0.06 divided by 4. So I'm starting here in the bottom, and then I'm going to add 1 to this, and then I'm going to hit equals. So it's 1 and some decimal. Now I'm not changing any of this. I'm going to raise this to the power of 20. I'm going to hit equals again. And I'm slowly accumulating information in this calculator. So now this is supposed to be, the way I've done this is it's in a numerator, it's supposed to be in the denominator. So in order to do that, I can press this reciprocal key, 1 over x. So now that puts it in the denominator. And I multiply that by 5000. And I get the same number, 3712.3, and we'll round up to 6. I'm rounding up because I don't want to be a couple pennies short. Have to go begging next door for a couple pennies so I can take my Tahiti trip. Okay, so that finishes this section off.